About 4.6 billion years ago, within the Orion arm of the Milky Way galaxy, a star was born. At first it was surrounded by a cloud-like protoplanetary disk that consisted of dense gas and dust. This star was our Sun, and this is how our solar system looked before the planets emerged. The mineral grains within the protoplanetary cloud began to accumulate, forming larger and larger chunks of rocky matter, starting the process known as accretion. As the rocky chunks grew larger, they attracted more and more of the smaller matter, forming the first asteroids. Until recently, it was thought that these asteroids collided with each other, slowly growing to form planetesimals and protoplanets. In 2019, the New Horizons probe flew by a strangely shaped object at the edge of our solar system. This object, named Arrokoth, consists of two lobes connected by a thin neck. Instead of being formed by a collision, Arrokoth's shape tells a story of gentle merging. This discovery points to a different hypothesis known as gentle clumping, in which orbiting material formed into clouds that gradually collapsed into themselves over time. Many astronomers believe that after millions of years of asteroid bombardment, Earth was struck by an object about the size of Mars. In what is known as the giant impact hypothesis, or the Theia impact, this cataclysmic event generated enough heat to liquefy Earth's surface, and turn it into a vast ocean of molten magma. Most of the material that was blown into space after the massive impact remained within Earth's orbit, and once again, the process of accretion began. Increasingly larger chunks of material joined together and formed a new orbiting satellite, our Moon. When this new heavenly body rose above Earth's horizon, it would have been a spectacular sight, geologically active and almost 16 times closer to Earth than it is today. At one point, there were three dominating theories to explain the formation of the Moon. The first, called fission theory, proposed that the molten Earth was rotating so fast that an enormous chunk of lava was ripped from its surface. The capture theory suggested that the Moon was initially an independent planetesimal that was captured by Earth's gravity. Finally, the co-formation theory proposed that the Moon assembled from leftover rocks and dust that remained after Earth's formation. Our science took a giant leap forward with the beginning of the space exploration era. On July 21, 1969, the Apollo 11 module landed the first people on the Moon. They collected 21.5 kilograms of lunar material and brought it back to Earth. Since then, almost 400 kilograms of lunar soil have been retrieved, more than enough material for scientists to analyze. Meanwhile, as Earth was recovering from the tremendous impact, its surface started to cool and harden. It began to form an atmosphere of carbon dioxide, carbon monoxide, water, hydrochloric acid, sulfur, nitrogen, and methane. This time in Earth's history is aptly called the Hadean Eon, named after Hades, the ancient god of the underworld. About 100 million years after the giant impact event, Earth had cooled sufficiently for the very first clouds to begin forming, and this is how the first rain in our planet's history began. It lasted for thousands of years, gradually covering Earth's surface with water, forming the first ponds and lakes and seas, until the entire planet was covered, turning it into an ocean world. For a long time, scientists believed that water was brought here by comets and meteorites. But when the Rosetta spacecraft analyzed comet water, the chemical signature didn't match Earth's water. The latest thinking suggests that water's constituents have always been here on Earth, trapped deep in the mantle and released through volcanic eruptions. As Earth was young and extremely active geologically, volcanic cones started rising above the water surface, forming the first bits of land. Over time, these small islands grew into larger land masses, the first proto-continents. It was the dawn of the Archean Eon. At this time, approximately 4 billion years ago, a very important event took place, the emergence of life. These first denizens of life were called prokaryotes, single-celled microbes that lacked a nucleus but possessed all the features required to fall under the definition of life. The emergence of DNA became the reliable storehouse of genetic information, while RNA became the workhorse that participated in replication and protein production. Thanks to cyanobacteria, life on Earth became visible to the naked eye as early as 3.5 billion years ago, forming layered structures known as stromatolites. Cyanobacteria did something revolutionary. They started employing sunlight for energy in a process called photosynthesis. This was the beginning of the transformation that would eventually make Earth the familiar, life-sustaining world we know today.